Every time we hear the news talking about Anonymous or those hacking groups being able to access CNN, Wall Street Journal, or those different government agencies, there is a common pattern. Most of the time, they use something called SQL injection. That's a vulnerability in web-based applications that has existed probably for the last 10 years, but it is still one of the top 10 vulnerabilities per OWASP standard. So here we are going to learn those different techniques, how you can implement an attack based on error-based, union-based, blind-based attacks, how you can dump the whole information from the database, or even how to get a remote shell. We invite you to take it and also to enjoy about our labs that are ready for you to practice. So we're going to talk about the definition about what is injection, what is SQL injection, the types of SQL injection that we have, SQL Map, which is a pretty good tool, open source, available in Kali, that can help you to automate this whole process. We're going to teach you how to do it manually and then how to automate it with a tool. So let's go about the definition. What is injection? Well, basically it is a malicious input that is going to be sent into a web application for processing. But injection can be SQL injection for sure, but it's not the only one. Can also be OS injection for you to, let's say, to inject commands to be executed by the operating system, or SQL injection, which is executed by the DB engine, LDAP injection, XML injection. So you can see there are multiple types of injection, not only SQL. But in our certification, we're going to focus only on SQL injection. This is the one most exploited vulnerability nowadays. You can hear about recent hacks on CNN or those different companies. It's always about SQL injection, most of the time. Let's talk about the first SQL injection, which is error-based. How it works. Basically, the way it works is you try to submit a malicious input, and based on the response, that commonly can be an error message, is going to help us to decide if it is an SQL injection and therefore focus our efforts. This is a typical response in an SQL syntax error message. For some reason, the attacker sends a malicious input, we get an error message coming back, and you can see that in this specific one, it says something about check your corresponds to your MySQL version and all the details. He's telling you that there is an error in the MySQL. Right away, you know that there is a MySQL engine in the back end, and then you can focus your tools and techniques in order to hack this specific web application. It's based on the error received. That's why it is called error-based. Here's another example. You can see, the question is this SQL error useful? In this example, related to CNN, we can see that there is an Oracle error message coming back. Just by looking at the error, the attacker knows that it is injectable, he knows that it is Oracle, and eventually, this was a real attack. They were able to dump the whole database. The key about SQL injection in general is to try to find a true response in order to do some damage. We have this typical SQL query when trying to log in into an application. The application is going to evaluate the username, which is provided in red color, then the password, which is provided in red color. And what we are seeing here is the 101 injection. We don't know the username, we don't know the password, so we said, okay, any username, any password, at the end we said, or 1 = 1. As you know, username we don't know, password we don't know, that's a false response, but 1 equal 1 is true, and therefore we can get access to the application. As I said, 101 is here, and in China is 1 always, so no doubt about it, and we get access to the page. We have labs about this 101 and more advanced stuff, of course. Let's talk about SQL comments. SQL comments is that when you have a specific SQL statement, if you put a comment, that is not going to be taken as part of the SQL command. It's going to be discarded. It's like in source code. You have a source code, all your code, you put a comment with a specific sign, and that is going to tell the compiler, don't touch it. It's not part of the code to be executed. Exactly the same in SQL syntax. It is very useful to discard specific attacks. Let's see how it works. Let's say that we have here this statement, select user and password from table where user is something and order by user. Let's say that we want to discard the order by at the end. So we inject something like, okay, user equal u, and then in red we can see our injection, which is colon or 1 equal 1. And then the dash dash means comments in MySQL syntax or my Microsoft SQL Server syntax. What it is telling is after dash dash is just comments. In other words, it's not going to be executed by the SQL engine. And therefore, the order by is discarded. The comments operands are different based on the DB engine. As I said, in MySQL, we can use dash dash, or we can use the pound sign. In Microsoft SQL Server, it is dash dash. Oracle has its own command to put the comments, so it depends on the DB engine. But as I said, it is very useful for you to discard the remaining of an SQL command. Like in this case, we get rid of order by. We will learn why we can do that in our lab. Next type of SQL injection is union-based. Okay, so once we found a bug, once we find that the application is vulnerable, probably via our error-based approach, we can do union-based. Union-based is going to help us to dump the content of the tables of that specific web application. There is a rule of thumb here. Union is concatenating two tables. Table in the left, table in the right. Both must have the same number of columns. Otherwise, you're going to get an error message. It's exactly like this. You can have any type of information to the left, but in the right side must have the same number of columns and the same type too, in order to union to work. From an attacker point of view, what we need to know then is, in a specific scenario, if we found a vulnerable application, and if we want to perform the union attack, we need to know the number of columns for that specific vulnerable section. By using order by, it's pretty easy to identify it. So basically, the way it works is that you start incrementing your SQL query injection, order by 1, order by 2, order by 3, and eventually, as you can see here, you get an unknown column 4 in order clause. That means when we get to the order by 4, the application throws an error and says, hey, there is no column 4. That is telling us that there is only 3 columns in that specific section of the application. We don't know the table behind, but we know it is 3 columns. Just because of that, we can start constructing a more elaborate attack. Let's see that. Now that we know that there are 3 columns, we can do this kind of attack. Okay, so we inject in red color, as you can see there, a quote, single quote, union, select 1, 2, 3, and as you can see, the SQL comments at the end, dash, dash, so that we don't care about the rest of the query, which is in the server side. We are just caring about our injection. If we execute this, we should get a response without any error message. That's just to confirm that we are going to the right direction. And if we want to extract information, you can see here that in the right side we have the union, and then we have select database, that's the first column, then select version, that's the second column, and then select hostname is the third column. Those are commands for MySQL specifically. If you want to do the same for other DB engines, you need to find the commands for those specific DB applications. In this case, we select MySQL, is the one that we are targeting right now, and then you can see that in the right side, there are 3 fields. Keep in mind, we have only 3 columns. We cannot do more. If we try to put another column in the right side, we will get an error message saying it's not the same number of columns in the left and right side. In this case, we just put those values, and you can see that at the bottom, we are able to identify what is the database name, what is the version of the MySQL in this case, and the host name of that specific server. So that's for you to give you an idea how the union-based attack works. You identify the columns, and then you proceed to do any kind of extraction. This is not the only thing you can do. You can get a remote shell just by using union-based. The way it works is you do a union select 1, 2, which is the first 2 columns, and in the third column, you put PHP code. That PHP code, you access another functionality in MySQL, which is outfile. Outfile allows you to write information into a file in the web server. In this case, we're going to write PHP code into a specific folder. You can see here the folder is web server/shell-php. By using union and a combination with this MySQL command, we can write a malicious file into the server. Eventually, that malicious file can give us access remotely. We have this exercise in the lab, so don't worry, we're going to see it in detail. But this is for you guys to see how powerful can be union attack. Here is the shell that we might be injecting, which is basically receive a parameter CMD, and that parameter executed via system, which is going to execute system commands inside the server, which in this case is the web application we are targeting. The way we run it, we said, okay, now that the shell has been uploaded into the server, we said, okay, CMD, execute Netcat, which is a well-known client like Telnet, that is going to say, connect to the attacker IP to the port 8080 and send a shell. What happens after is you get a shell inside the web server. Again, we have a good exercise about this. Okay, let's talk about blind SQL injection. So basically, the difference between error-based and blind is that in the error-based, you get a response from the website. In the blind approach, you don't get anything. So you just inject something, but you don't get anything in the response. That means you need to guess if you are injecting something successfully or not. That's the way it's called blind. If you are wondering if blind SQL injection is common, well, you can see Tesla Motors was just hacked months ago, and all the time we're seeing blind SQL injection. It's pretty easy to exploit, and it's just a matter of time to find it if it is vulnerable. As I said, the server does not provide information when we try to inject it. We need to ask the server for different questions to know if our injection is being successful. And there are 2 types to do that, 2 types of approaches. The first one is the Boolean based, which means we're going to ask true, false questions. And if we get a true value, that means we were successful in our question. If we get a false response, we said, oh, we didn't success. That's the way we can identify it. Basically, what you do is you send a request, and you need to get a response in the web server, in the website. Let's say that you send a request and you get back a welcome, and then you send another request and you get back not available. So you identify two different responses. Based on those responses, you can check and say, anytime I receive a welcome, that means my command was executed successful. But if I get a not available, that means that my command was not executed successful. That way, you can automate it and say, every time you get those kind of responses, I know if I am going, am I extracting information? We're going to see an example right now. The second approach is time-based. Let's say that you don't get a response from the server. You don't get like welcome or not available. You don't even get that. Then you can say, okay, inject something and wait 5 seconds if the command was successful. If not, don't wait. So by checking the delay in the response, you can identify if your command was successful or not. A real scenario is like you can say, hey, is the database starting with letter C? Wait 5 seconds in the response. If not, response right after. If you suddenly get a response with 5 seconds delay, you know that you found the first letter of the database. Then you move to the next one, and then to the next one. And by checking those time-based or true false responses, you can identify if you are succeeding in retrieving information. Let's check an example of Boolean-based. As I said, the attacker sends true or false questions. And let's check here how we can extract one char in MySQL. Just without any attack, we can use the substring function. The substring function is going to receive a string. Then in the second parameter, it's going to say where is the starting offset, in this case 1, which is at the beginning. And the last parameter, the number 3, is how many chars you want to retrieve. In this case, is 1. So we are saying, give me the first char in the string database. Select database is going to give us the database name. In this case, let's assume that our database is named CSTT, and then we're retrieving the letter C by following this approach. So now let's see how the attacker can use this specific function maliciously. They are going to start trying to identify what is the first letter in the database blindly, right? So they can say, hey, like in this case, we said select substring from the database, the first value with the offset 1, only one char, which is 1, 1, converted to ASCII, which means that letter converted to the number, to the decimal number. And then we check if that number is 65. We know that the first letter is letter C. That in decimal is 67. So that's why that when we are asking here if the letter is equal 65, we get a 0 response, which is false, right? If we want to get the letter C, we need to ask for the 67. Let's see how that works. If we ask here for the 67, you can see that we get a 1, which is a true response. In other words, the attacker was able to identify the first letter. You can automate this. You can say, okay, it is letter 55, 56, in this case, sorry, 65, 66, 67, 8, 9, until it gets a true response. Once he gets that true response, means I found the character, and then I move to the next one in the letter. Like in this case, let's say that we found the first letter, which is letter C. Now the substring is going to say, move to the next offset, position number 2, and also get just one character, as you can see there. And start again the loop. Okay, now the second character, are you letter E, B, C? Eventually you get a true response. That means you find the next letter. So that's the way it works. Again, we have examples in our labs for these specific scenarios. Time-based is exactly the same, but instead of asking, waiting for a true or false response, we just set a delay. How it works, let's see an example in MySQL. We said, hey, if the ASCII of the first letter is equal 65, wait 10 seconds. You can see the wait for delay means wait 10 seconds in SQL Server. So that means that if we found the letter, we're going to get a delay of 10 seconds in the response. That is telling us we found the char. We have other options with other DB engines. For MySQL, for example, you can use the sleep operand instead of the wait for delay, or you can use the benchmark operand also. It depends on the DB engine. We have examples in our labs. Obviously, this approach can take longer. Can you imagine if you want to enumerate a big database with multiple tables, multiple columns, multiple content? You are going chart by chart, enumerating the database name, and then the first table, and then the second table, then the first column of the first table, second, chart by chart. I mean, it's doable, definitely. You can leave it running for 24 hours probably, and eventually it will get information. Can be prone to FPs also, because let's say that you ask your program to wait 5 seconds and the response from the server is slow. Probably the response is taking 5 seconds and you might think that you get a hit, but probably it's just because of the traffic, not because of the response. But it's also definitely a good approach, always recommended. If you cannot do Boolean-based, you move to the time-based attack. We have an example with SQL map so that you can see how it works. Here are very good references about SQL injections. Basically, those references will give you examples of every single engine. Those references has been there since probably 7 years, 8 years ago. Nothing has changed too much. So you can go and check Pentest Monkey and Ferrum Mavituna. So those are very good sources for you to know all the different commands for all the different versions. SQL map. Let's talk about SQL map. This is an open source tool, probably one of the best tools in the market, open source, for you, available in Kali. That is going to allow you to dump the whole content of the database and also even get a remote shell into the system. And it's pretty convenient. The requirement is normally you need to get a vulnerable parameter so that you can help SQL map. I mean, you can just leave it the URL and it will try to find it, but that can take time. But the best approach is to find the vulnerable parameter and provide it to SQL map. It supports multiple databases, as you can see here. That means it can be able to inject into those databases. Depending on the database, it can do some things and some things is not possible. Like, for example, to write a file into the file system, the database must be able to have that feature to write files into disk. If it doesn't have that feature, there is no way for SQL map to do it because it relies on the capabilities of the DB engine. MySQL, Postgres, Microsoft SQL Server provides the functionality to write into disk. So it's useful. It uses the techniques that we are just describing, error-based, blind-based, union-based attacks, but automated. It can enumerate, as I said, all the database names, tables, columns, and content. It can give you a web shell in PHP, ASP, Java, ASPX. For that specific feature, as I said, you need, for MySQL, for example, you need to have the file permission granted, which means the database user must have the permission to write into file on disk. That's important. You must also find a writable directory by the DB engine. If you're running MySQL, the MySQL user must be able to write into that specific directory in order for this attack to work. And examples of how to use SQL map, you have here a simple example. You set -u, you put the URL, vulnerable one, and it's going to start doing the magic. Second thing is you can say level 5, which means you have different levels depending on the level is the number of tests that it's going to perform. For example, if you say level 1, which is the default, it's going to perform around less than 100 attacks. But if you increase it to level 5, you probably are talking about more than 500 different attacks. So depending on the needs. Obviously, the performance is involved if you increase the level. V3 is just verbose. Basically, V3 is going to allow you to see all the injections being executed. It is called payloads in SQL Map, so it's another option. As I said, it provides a web shell via the out file or dump file options in MySQL, but it does the same for other engines. Its own commands per engine. With the -os-shell option, you can get a shell into the web server. We do a lab doing it manually by ourselves and with SQL Map so that you can see how it works. It's very important for you guys to know how to do it manually without relying on any tool. In case the tool doesn't work, you can still do it manually or create your own tool if needed. Here is just an example of how you can load it into the web server. You do select the PHP web shell. In this case, it's a PHP application into out file, and you put the destination file and the destination folder. You have other options. As you can see here, you can retrieve everything, the banner, the current user, DB, password tables, everything. I mean, you can say just dump all, and if the injection is successful and you have the right permissions, because keep in mind, this whole thing is executed on behalf of the database of that web application. Depending on the permissions of that DB user, SQL Map is going to be capable to do all those features. It can even say, if you say dump all, it might be able to dump all the databases with all the contents. You don't know, based on the example. Here's another example. You can say, okay, dump all the tables with this database CSTT. With -d you provide the database. With -t you provide the table, which is users, and then you can dump the contents of that specific table, as you can see here in the example. A recommendation: as soon as you find an SQL injection in a real scenario, in a real pen testing effort, pass it to SQL Map immediately. Don't waste time. Let him do its own job and move to the next vulnerability. Mitigation strategy, as usual. Security code reviews. Is highly recommended to do security code reviews to find vulnerabilities before moving your code to production. Keep in mind we have our certification, Cybersecurity Source Code Defender, which can help you to know how to find vulnerabilities in the source code. Parameterized SQL queries is mandatory. We have an example in the labs for you to know how to implement it. We have obviously references that can help you also how to implement it in every single application server, Java, .NET, ASP, PHP, all different examples. Database firewall, this is pretty cool. This SQL LASI is kind of new. It's really cool because it's a new way to protect the database. So basically, it will be able to detect attacks at runtime. It's just a wrapper. Basically, you connect your DB engine to this wrapper. It's transparent for the application. The application can be vulnerable, but this is like a firewall in front of the database. And it's going to detect SQL error messages, union-based attacks. I mean, all the different kind of attacks. The bad news is it's under development. It's not stable or too stable yet, but I'm confident it's going to be a really good aid for those kind of vulnerabilities. Another approach is web-based firewalls. OWASP Mod Security CRS is an Apache Mod Security web application firewall, but customized in order to detect those different applications related attacks. Pretty convenient to take a look. Some features, it can detect HTTP protocol violations. You know, if you inject some specific HTTP commands that are not supported, blacklist lookups, you know, DOS protection if you want to do a denial of service attack, many different web application attacks, which obviously is what we are focusing right now. So it's highly recommended to implement it. we have multiple examples. Summary, guys. So in this specific course, we learn about different types of SQL injection, how you can test them, what is the difference between them. We found how to find columns, how to find tables, how to leak the information from those, doing it manually or automated by using Boolean-based, time-based, error-based attacks. As I said, we found how to enumerate tables with blind SQL injection. We talk about SQL map tool for automation. All these different points are going to be explained in detail also with hands-on labs for you guys to practice it. Hey guys, so welcome to the SQL Injection Lab. This is part of our Cybersecurity Web Application Defender certification. I recommend you to look at the slides related to this specific vulnerability, because there is where I explain all the different types in detail. Here we're going to be doing exercises, so we assume that you already understand those different concepts. We're going to be using OWASP practice exercises, which is available in internet. And this is just the baseline. We're going to be doing more advanced stuff. And we even modified some of the exercises too. Keep in mind that we are going to be playing the gray hat hacker role. That means we're going to be trying to find vulnerabilities in a black box approach, where we don't know anything about the application, and the intention is to find vulnerabilities in order to report them to the organization and come up with a mitigation strategy. In this first class, we're gonna talk about error-based injection. That means based on the response received after an injection, which commonly is a SQL syntax error, then we can decide our next step in order to perform a successful SQL injection. So let's go to the first example. In this example, obviously, if you enter something here and you click login, you will get an invalid username and password. If we put something, let's say in the password, like single quote, we can see that we get the typical SQL syntax error. This kind of errors is very common when we are dealing with error-based attacks. You are getting an SQL syntax error, which is telling you what is the DB behind, in this case MySQL, and what is the problem. You need to be able to understand the problem in order to come up with the next injection attempt. Whatever is inside these first single quotes, there is one single quote here, difficult to select. That first single quote and this last single quote, those are part of the error message, so don't care about them. Whatever is inside, which is this, that's what it matters. So what it is telling us is, as you remember, we inject the 222 single quote, right? After that, we can see that there is another single quote and then a limit 01. That means that after our injection, the program is concatenating with this single quote space limit 01. And because of these two double quotes, we are getting a problem, a SQL syntax error. Let me show you the source code. I don't wanna, obviously in a real scenario, you won't be seeing the source code, but from learning
learning perspective, I think it is very important. So let's open it, the program. As you can see in the error message, we are seeing this single quote limit 01 right after our injection. As you can see, our injection comes into the pass variable, and after that it is concatenating with this. We saw that just in a moment. We saw it. So what we are gonna do in order to bypass it is just pretty simple. We need to try to find a way to execute first an SQL statement that doesn't generate any SQL syntax error, and second, that it returns a true value. If it returns a true value, it's gonna say welcome to the application. A typical scenario is this. I'm gonna just move this concatenation a little bit to the right so that it can be clear. Here in the pass is where we're gonna put our injection. So let's say that we put the 222 single quote. If we leave it as it is right now, we're gonna get the SQL syntax error, as you remember. But what we are gonna do is, after the single quote, we know that we don't know the user and the password, but then we do a or single quote 1 single quote equal single quote 1. That's it. Why? Because when we do that, we know that the remaining thing, this right side, is going to be concatenated. And when it is concatenated, as you can see, we just built a right SQL syntax. And not only that, we are saying that the usernames, if the username and password, that's false, because it's going to return false because we don't know the username and password. But then we say or 1 equal 1. We know that 1 is always equal 1. That's going to return a true statement and then should give us access into the session without knowing the username and password. So then, as you learn, we're going to try to inject this without the last single quote. Just let me recover my original PHP file, and let's go to the exercise again. So we come here and we say or 1 equal 1, and then when we click login, we are inside the administration. So we just saw the basic 101 SQL injection. It was very important for you guys to understand how you can build those different SQL injections based on the error received. It's very important to understand it. That's why you need to look at the error message received in order to construct the SQL injection. Let's check another example, the lesson number 2. In this example, it's a double quote. Basically, it's exactly the same, but if we put a single quote here, we can see that it says invalid username and password. But if we put here a double quote, we get again an SQL syntax error. Here you can learn that sometimes if you try with single quote and it doesn't work, then you can try with double quotes. So you need to move to different characters. But to be honest, automation can help us a lot, so we don't need to do this manually. We need to understand how to test these kind of vulnerabilities manually so that we can confirm when the scanner finds a vulnerability. But in the real world, we are not going to be doing this manually. Can you imagine hundreds of parameters in a big application? We cannot do it manually, right? So here is going to be exactly the same approach. So as you remember, we're going to say or double quote 1 equal double quote 1, and then the remaining is going to be concatenated by the program, and then we're going to get access to the admin again. Pretty simple, but it's important for you to understand. Let's see the third example. In this third example, we have Seagate, we have different products. When we click on them, we can see here that the code is being changed. So if we try to put here a single quote, we don't get anything. If we put a double quote, we can see that with the double quote, we're getting an error message. As I said, it's very important to understand how to read the SQL error message. In this case, you can see, and let me put it a little bit clear. I'm gonna do something like blah. You can see that our blah double quote is right here. After that, there is another double quote, parenthesis, limit 01. We know that this is now what it is being concatenated in the right side. So we can try to do something here. What we can do is we put the double quote, the parenthesis, and then instead of leading with the remaining, we can just put a comment. The comments are in SQL queries tell you that whatever is after the comment is not going to be parsed. In other words, it's not going to be taken into consideration. So we are saying here basically, okay, close the SQL command, and after our dash dash, and we just put a space here, don't do anything else. We execute it, and you can see that we are not getting any error message now. That means might be working. We can confirm that it is working if we do something like, okay, after this SQL, we say or 1 equal 1. You can see that we are getting all the results in one shot. This means we are properly executing our query. We can say or 1 equals 0, and that's not going to return anything. That can give you a clue that your execution is being done. So, and just quickly let me show you the source code also, so that you can also understand what was going on here. It was lesson 3, and you can see here in the source code, you can see that as expected, it was our P code injected, and in the right side, the program is concatenating it with a double quote, parenthesis, limit 011. And what we did here was this. We said, okay, you're waiting for me. Then I'm gonna do we did blah equal, we close it, and then we say, hey, don't do anything with the remaining. That was what we injected, something like this. And then we said or 1 equal 1, 1 equal 1, and after that we said just don't do anything. Oh, sorry guys. That was exactly what we just did in the program. Okay, pretty simple, but important for you guys to understand. That's basically error based. Everything that you get an error message, SQL related, analyze the error and build your next execution. Okay, so let's talk about union-based attack. If you remember, we were able to inject our code right here. Now that we have SQL injection working, our next step, if we want to do union-based attack, is we need to identify the number of columns being executed in this specific code. So we know that here is a code, but this code is bringing, just by looking at here, looks like it's bringing three columns, right? Product ID, product name, and price. This might be looking kind of pretty easy to find, but in other scenarios it's not that easy. So the way that you can find the columns is by using the order by. Every single DB engine has its own technique, but here we're going to be dealing with MySQL. So what we can do here is we can just only say order by 1. We can see that it doesn't say anything. Then order by 2, and you can start incrementing it until you get an error. You can see that when we set order by 4, it says, hey, column 4 in order clause is unknown. That means we don't have 4 columns, we only have 3, which we just knew before, but we are just confirming it. So this way, by using order by, you can find the number of columns. Now that you have the number of columns, then you can prepare your union-based attack. Union is basically concatenating two tables where the left and the right table must have the same number of columns. That's the reason we found the number of columns here. So now we can, and by the way, we rely on the specific resource in the web application being tested. Sometimes the application might have 8, 12, 1, or 2. It depends. Once you find it, you can do something like this. Union 1, 2, 1, 2, and 3. Select. And you can see that we are concatenating the result and we are just printing 1, 2, 3. This is just telling us that our union base is working. Even if we try another column, it says, hey, the use select statements has a different number of columns. As we explained, it's important to have the same. Okay. Now we can start playing with these values. We can, for example, here put something like we can start gathering information. We can say, hey, give me the database. You can see it says OWASP practice, and these are commands for MySQL. Again, the same is applicable for other DB engines, but different syntax. In the second one, we can say, okay, here you probably give me, let's say, select the MySQL version. You can see it here. And in the third one, we can do something like, let's say, select the host name. So basically, you are seeing that we are able to retrieve information from the database because of our union select. But we can do more than that. Obviously, we can start listing tables, columns, and eventually we can even list contents, and we can dump the whole table. Again, this can be done in an automated way, and we're gonna have a class about SQL map where you will see how this can be automated. But it's very important also for you guys to do it manually. What if the tool doesn't work? What if you need to change the tool? It's always a must skill to be able to do it manually. So let's try to retrieve the content of a table, but first we need to find the tables. In order for us to find the tables, we need to start doing a specific selects. Since it is MySQL, we can do something like select table name from information schema dot tables and limit 1. You can see that we got our first table here. The reason I set limit 1 is because if you don't do it, let me show you, it's gonna tell you it is returning more than one row, and depending of the scenario, sometimes you can retrieve everything, sometimes you cannot. You can use other techniques to concatenate everything, so there are multiple ways. So here we got the first table, and here we can say something like where table name not like, for example, not like something like C and whatever starting with C. You see that we now got engines. This is just one example, but you can start doing it with all different ways. So we can, for example, say, okay, so now give me the table, let's say here, give me where the table, let me just remove this so that you guys can understand it, where table like, we're gonna say here, where table like whatever it is at the beginning, and then login, for example. You can see that we found the table SQL login. So I mean, there are multiple ways, but obviously this can be automated, right? But I'm just teaching you how you can find it. So we got the table, right? Once we got the table, we can go and get the content of the columns. In order to do that, we can do something like, let me show you here. I just want to remove all those encoded strings for you guys to be able to understand it. Okay, so here we start writing our new SQL. We can say something like select table name from information, we have it here actually. Okay, so we are saying just select table name from information tables. Okay, where table name is equal to this guy, the one that we just found. So we run it and select the from oh, here is from columns actually. Table schema columns where table name. Okay, and here, sorry, we say column name. So you can see that we retrieve the first one, which is username. Again, we can say something like where table name is this table and column name not equal or not like username, and we get the password. So multiple ways to play with this guy. So now we have the table and also we got the fields. With the tables and the fields, as you can imagine, we can retrieve now the contents. We can say something like select from this table, select password from this table. and we get password, which is the same, or select username, which is admin. So we just learn how we can start dumping all the information starting from the database, then the tables, then the columns in the tables, and finally the content inside those tables. So this is all based on union based. There is other very cool techniques with union based. You can get a remote shell, for example. That's a different class, but hope you enjoy this class, guys. It's union based and is very powerful. This is all MySQL, but it is the same concept applicable to other engines. Different tables, obviously, but same concept. Okay, so let's talk about blind-based scenarios. When we talk about blind-based, guys, this is all about, it is commonly the same as error-based. The main difference is that in the error-based attacks, we get a response, right, from the SQL server, from the website. We get an SQL syntax error. With the blind based, is in the scenarios where you guys don't get any response. You don't know what's going on. So then you need to find a way to dump the information. Basically, the injection is exactly the same, but in terms of the techniques, at the end, you will be trying to retrieve information, but the way that you execute those SQL queries is different. I'm gonna teach you how you can do it. So basically, in blind injection, you have two approaches. You have the Boolean based, which means you will ask the website and the application about true or false statements, and depending on the response, you will decide if you find something inside. You will decide if you get a result expected. Like, you can ask the table A, is the database starting with the letter A? If you get a true, that means is letter A. If you get a false, that means it's not a letter A. That's kind of the Boolean approach. And in the time based, basically you said, if you are the letter A, wait 5 seconds to respond. If you are not, don't wait. So eventually, if you get a delay of 5 seconds, that means you find that specific letter. Don't worry, we're gonna do exercises about it right now so that you can understand it. So we go to the lesson 4. In the lesson 4, actually I changed this exercise. The original exercise was not 100% blind because it was printing the results, and that was kind of easy to find. So what I did was, every time you click on something, you just get a password found. That's it, nothing else. If you don't put the right code, you will get a product not found. Okay, so let's talk about the Boolean based approach first. So what you can do here is, let's say that you put a single quote. As you can see, we didn't get any result, right? We didn't get any SQL syntax error. So we don't know if there was an error or it was normal. We don't know. If we do a double quote, we can see that says product not found. That means that probably with a single quote, there is something weird. The typical way to test it is, we need to try to inject a real SQL injection to see if it is retrieving information. So we can say something like, okay, so I don't know what you are here, and we can say or 1 equal 1, and then we put our comments. By the way, you can also put this, or you can put the percentage 23 which is the signal of the pound, this guy, but we need to encode it. Okay, so it's the same. So we can use the percentage 23. When we execute it, we are saying, hey, the code, I don't know, or 1 equal 1. That returns true, and it says product found. Let's say that we say or 1 equals 0. We can see that we got a product not found. This is the first step that you need to do when dealing with Boolean based attacks. Basically, you need to find two different responses. One when it's a true statement and one when it is a false statement. And the reason you want to do that is because that's the way that you're going to confirm if it was a true or false statement. Now we know that when it says product found, that means we got something. And when it says product not found, that means it was a false statement. So now that we found those and we confirm that our blind SQL injection is working, let's try to retrieve some information. The way we do it here is a little bit different, and we're going to be using some is again based on the DB engine. In this case, we're going to be using some string related operations. So let's start with ASCII, and which basically converts a decimal number into the character. So we're going to say ASCII and then substring. Substring is just going to retrieve a specific character or characters from a string. So we're going to say substring, and then to the substring we're going to say select. Let's see that if we can guess the host name. So we say select host name. Okay, so if you remember, the host name was CSTT, Cybersecurity Think Tank. Okay, so we're gonna try to guess it. Select host name, and then we close the substring, and we say, okay, for substring, get in the offset 0, which means in the first letter, that's the 1, only get 1 character, is what we are saying here. And then we just close it, and we say something like if it is less than 100. Okay, sorry, I did something wrong. I said that the ASCII was converting from decimal to character. No, it's the opposite. It is going to convert a character into the decimal representation. So in this case, we're saying that, hey, the host name, get the first letter. Is that less than 100? So that you know, guys, the letter C in decimal is 67. So that means this should return a true statement, and let's test it. We get like an error message here, so probably we are missing or we are doing something wrong. So let's try to find it out. Probably we have here the ASCII. Let me check. Or 1 equal 1. Oh, here we need to say here and. Yeah, we forgot the end. Okay, so you can see that we got the product found. That means that our letter is less than 100 in the decimal representation. As I told you, we know that the letter is 67, right? So let's test it. If we do equal 67, that returns product found. If we do equal 68, it returns product not found. As you can see, we are guessing. Obviously, this can be easily automated. So basically the program is going to say, hey, are you 66, 67, 68, until it gets a true response. That's why it's very important to understand the true and the false responses from the website. Okay, so we guessed the first one, we know that, right? So the second one is the letter S, which is the number 83. So we can say here, okay, now go to the offset number 2 and also get only one character. And you should be 83. Okay, this should return a truth statement. You can see the product found. So you got the idea, right? So you move to the second, and you can move to the third, and you can move to all the different characters. Now we go to the third. The third is letter T. Letter T is 84 in decimal, and we get it. If we would have asked for 83, we get not found. So you guys got the idea, right? So basically, you can ask for a specific questions, true or false questions. Depending on the response, we can decide if it was a match or not. Eventually, here right now, we just guessed the database, which can be easily automated. Okay, guys? Ping me in the social network. As you know, there are multiple students there interacting with all those different exercises. You can always ping me in the chat or ask another students. That's the power of our social network. Now, let's talk about time-based. Time-based is essentially the same approach, but instead of trying to see the response, let's say that we don't get this product found, product not found. We don't get that response. We don't know if it is a true or false response. The way to do it is by a delay. So let's say that in this case, let's say that we do something like, okay, 84 and sleep 2 seconds. So what we're gonna say here is, hey, if you are 84, which we know it is, sleep for 2 seconds. We're gonna run it and check this. You can see connecting is not responding. That's because of the sleep. Eventually it responds. You see that? Let's try to do with another number. Let's say 83. You can see what 83 we didn't delay anything. It was just an immediate response. Obviously we do the same for any other number, right? We don't get anything. But as soon as, let's try the first one, which was the 67, and therefore we go to the first character here. If it is true, sleep, and you can see that it is sleeping, connecting, and eventually will respond. You see that? So that's time-based, and it's exactly the same approach, but instead of relying on the responses, you put a delay, and if there is a delay, that means you find a specific character. So these two approaches are very important for you guys. It can be automated, and I'm just gonna show you what is the difference in the source code. So basically, when you open the lesson 4, which is the blind based, you can see that in the OR die is not printing anything out. There is no SQL error message. Let me open the previous one, which was lesson 3. In the lesson 3, in the SQL query, there was a die MySQL error. Okay, and in the blind based, it was just nothing. That's the first approach that we saw. Also, in the first one, which was error based, we can see that it was printing out some content. In our case, it is just saying product found or not found. There is no clue, and there is no SQL error message. That's behind the scenes how this what is the difference between blind and error based attacks, guys. Hope you enjoy it. Okay, so we understood how error-based, union-based, blind-based attacks works, right? So it's time to do some automation. There's a tool, pretty cool tool, which is called SQL Map. That tool was obviously presented in our slides. It supports multiple databases and it can automate a very successful way all what we learn. So let's try to do some exercises. We can do SQL map, okay, and then with dash u, obviously you can do dash h, and it's gonna give you all the different options, or you can do dash hh, and it's gonna give you more information. So let's grab our injection here. This guy, and we get just until the code. So we say HTTP, and this is our, oh my god, we already have it. Okay, so this is our URL, injection in vulnerable URL, and we can do 4 or 3, doesn't matter. Let's start with the 3 one. Okay, so we do this, and then after that we can ask like, hey, give me the current database, for example. So let's try to run it. Oh, sorry. So we start running it. It will say get parameter code might be injectable, possible MySQL. Do you want to skip test payloads specific to other DBMS? Well, we say yes because we know it's MySQL. It says, hey, for the remaining tests, do you want to include all tests for MySQL extending level 1 and risk 1? That is saying, do you want to do other tests, not only level 1 and risk 1? Basically, level 1 means it is a set of samples less than 100. Level 2 is more than 100. Level 3, 4, 5. Eventually, you will have multiple tests depending on the level. And the risk means level 1 means it cannot be too risky. It cannot damage the integrity of the database. Level 3, for example, can do injection in updates or deletes, which can, harm the database. Sometimes it's not needed. So we're gonna say no in this case. And we're gonna start doing some different tests. And you can see that it says code is not injectable. We know that it is injectable, right? Because we tested it. So what we're gonna do here is we're gonna increase the level. We're gonna say level 3, which means do more testing. Try to do more testing, not only that. Again, the same questions. We say yes, skip, don't test other databases, and we say here again no. Since it is level 3, it's gonna start doing other injections, which obviously is gonna take longer than expected. We let it run, and it says, in this case, it says the code is vulnerable. As you can see, do you want to keep testing the others? We said no. I mean, you already found it vulnerable, so you don't need to start trying to find other injections in other parameters. Actually, we don't have other parameters, so we say no. I messed it up. Let's run it. Oh yeah, sorry, no, I didn't mess it up. So you can see that in the response it says, okay, we found that it is a Linux operating system because of the select. You remember the select DB, select hostname, those things. You can easily find it. It says that it is Apache, PHP. This is the DBA, the database, and here we can see that it found the database, which is in this case OWASP practice. Okay. With that database, we can do more things. We can say -d, this database. Now give me, for example, the tables. tables. And you can see that right away it gave us the 8 tables inside OWASP practice. And we can go a little bit more. I mean, you can either even say, hey, just dump all from this specific database. And it's gonna dump everything, guys. You can see here, it is dumping the contents of everything. You see? So it's kinda everything. It's pretty awesome, pretty fast, and pretty convenient. So this is the way it works. SQL Map is pretty fast. We're gonna be teaching also how to get a remote shell through SQL Map. That's another class, guys, so look forward to it. It is a remote execution class. But I want to show you something extra here. SQL Map is pretty configurable. You can tweak it. You can use prefixes. Like if you remember when we first running this guy, it was not running without level 3. You remember that? We need to put level 3 in order for it to run it properly. And we can do something like prefix. We knew that the prefix in our case was a double quote and parentheses. If you don't remember, check it in the error-based class. But if you might remember, we were using this double quote parentheses in order to do a proper injection. So in this case, we can tell SQL Map, do you know what? Try to do prefix with this, like giving some help. And you can see that right away it found the database by using our suggestion. That helps in performance, so that instead of testing multiple things, you can help it. You can also do debugging, which if you go to level 3, it's pretty cool because you will see all the injections being done. In this case, it's not visible, but in other scenarios you can see all the testing being done. You can also pass like proxy URL. I don't remember the option. We can go quickly to SQL Map and do -h, and we can do -hh pipe grep proxy. We can see that we have the proxy option. This proxy is basically if you want to run it through a proxy to, for example, intercept the request with burp, and you want to stop it at a specific point, you can do it, or you can use Tor. So the way it works is that you just say, okay, so proxy, and you say 127.1. I mean, this can be something like this, and then it's gonna connect through your proxy. You can see that it says unable to connect to the proxy because we don't have a proxy, which makes sense, but that's the way it works. And finally, let me show you something pretty cool. All the tools are in user share in Kali. So if you can go here, to ls, and you can see all the different applications running here. If you go to SQL Map, we have everything here, and I want to show you what is inside XML because it's pretty configurable. So you can go to errors. You can see that in errors, SQL Map has the list of errors per database, so that it can understand when it is doing error-based attacks what can be the common error messages for every single database. They support many databases, as you can see, MySQL, Postgres, SQL Server, Access, Oracle, SAP, DB2. It's just around 10 of them. Firebird, but this is pretty useful. And you can also add a new error base if you find a new one. and it's gonna take it. The queries also is pretty convenient if you want to learn the different injections, how to retrieve values from the database. Sorry, no injections, just retrieve values from the database. Per database, you can go to this place. You can see, for example, when you do some kind of banner, it's gonna say version is the command. When you ask for current user, it's gonna execute current user. This is the command. Database, hostname, as you remember, we use it, and everything. Table comments, column comments. We do this manually. You remember the information schema tables, columns. So okay, so but it is all this information, you can find it, and for all the different databases. So it's pretty convenient if you want to learn how it works behind the scenes. And finally, last but not least, the payloads. The payloads is actually all the injections being done, and it comes in a specific format. Let me show you quickly. Boolean. Sorry, I forgot to mention something. These different injections payloads is depend on the technique. You can see that it is a Boolean blind, error based, inline, stack, time blind, union query, depending on the technique being used, as we learn. So let's open the Boolean, and let me just go down so that you can understand this. You can see that it has many tags, and let me go down. Let me add one split here with this same. Okay, so we can move forward. Let's see some exercises. Okay, you can see here it says a test, which has a title. The title means just what are you doing here. In this case is an Boolean based blind in the where or having clause. It says the S type equal 1. The S type, we can see it here below, which is here the S type, it says which is the SQL injection type. 1 is for Boolean, 2 is for error based, 3, 4, 5, depending. That's why in this case we're dealing with Boolean based, and that's the reason of the letter 1. In the second, it says the level. As you remember, the level is going to tell you how deep you want to do your testing. You can create one specific test that is weird to use it, and therefore you might want to put it in level 4. So just when SQL map is told to run at level 4, it's going to be executed. The risk is that it's telling you if it is going to be damaging the integrity. As I said, if you put a level 3, for example, it will try to do some injection in updates, deletes, which is going to harm the database. The clause is where the injection is going to be applicable. Can be in the where or can be in the table columns. So let me show you here where is the clause. Right here. It can be in the where, having, group by, order by, limit. So you are telling basically where is going to be the injection, when it's going to take place. In this case, it says clause 1 because we know it is in the where clause. And finally, the most important steps. The most important part is the vector and request. Here is the injection. The injection, the inference is substituted by SQL at runtime, and in the request is saying what you need to inject, and the response is what you need to do in order to compare and understand when it is a true or false statement. That's why you have the comparison here. It is saying, okay, here is the payload for you to inject, and here is the payload in the response that it needs to match in order to know if it was a true or false response. It is the same for many other ones. You can look at the next one. This one is having clause, and this specific one has a different payload. This is or instead of and, as you can see. This one has also a comment. The comment is saying this is the comment based on the SQL syntax that you want to put at the end after the suffix. And let me just go to the end. This is just for SAP, but I just wanted to show you this has another vector, another payload. You can see here it has a select, case, when. I mean, it depends on your database, but you can always put your own payload here if you want to do something special. Normally it's not needed because you have the prefix and suffix, which can help, but definitely it's something that you want to look at it. So that's pretty much it with SQL Map, and hope you enjoy it, guys. The final step, I think, is the most excited one. So we learn about different SQL injections. We learn how you can definitely do some injection in different techniques. We were able to dump all the content from the database remotely, but we always want to do a remote shell, right? We always want to have a remote shell in the server. You know, that's something that is really excited, and we are gonna do it here. We're gonna do it manually and automated. So let's try to do it manually. The first technique we're gonna be using is into out file. Basically, what that means is, depending on the database, you have different commands, different options that you can use in order to write into the file system. Obviously, MySQL SQL Server, those are able to write into disk. Postgres SQL too. So you need to find the correct syntax. Let's try to do it for MySQL here. So we're gonna do our union based, as you remember. And in the union based, we're gonna say something like, okay, union, and we're gonna say select. Okay, you remember, guys, it was 3 columns, and the third column I wanna put this, guys. It's like a web shell, pretty simple. We're gonna say, okay, PHP code, because we know it's PHP. Could be ASP, could be JSP, depending. And then we call the system, which is execute commands. We can use also pass through. There are many. We can do bypassing, but it's not the case right now. So we say system execute, and what you're going to execute is whatever you received in a get parameter, and the get parameter is going to be named CMD. Okay, so that's what system is going to execute, and we finish our script with the question mark greater than is commonly when you close your PHP script. And then what we are gonna do is we close the single quote and we say into out file. Now here are two couple of things that you need to know. In order for this to be a success, first of all, the MySQL, in this case user, which is running the SQL statements, must have writable permissions in whatever you want to write it. Okay, you need to find a directory that can be writable by MySQL user, because MySQL user is the one executing this command. Normally can be found in upload directories, images directories. Those are the well-known places where you can upload it. Depending on the context might work or not. So we're gonna be uploading it here in bar www. That's another thing. You need to know where is a true directory. You can brute force this, obviously. You can brute force it pretty easily. So we have a directory which is upload, and here we're gonna try to write. Basically, we are saying try to write this shell into this path, and finally we do our comment. So let's try to see if this works. So we execute it. Oh, sorry, we're in lesson 4, which is blind. We need to move to lesson 3, actually. So we execute it and it says, hey guy, you have a syntax error, which obviously is very common. So let's try to find the syntax error here, guys. So it says union select 1, 2, then we put our PHP system, this is not a problem, into out file, and the out file syntax looks like it's okay, and probably we're missing something here. What should be the case? Oh, I know the problem, guys. You remember in the lesson 3 our injection was with this guy. You see here, double quote parenthesis. In order for our injection to work, we need to put double quote parenthesis and then our injection. So we execute it. It says file already exists. So probably we already upload that one. Probably I left that one before. So let's try to use another one. X2. We can see that it says probably is working. So let's try to test it if it is working. We're gonna try to access this guy. So let's go to that specific place, which is right this. Okay, we try to access it and it says cannot execute a blank command. That means it is up and running, guys. So we pass our get parameter, and let's say that we say something like cat etc pass wd, and boom, we are executing commands remotely, guys. So that's what I promised, right? No, I promised a shell. So let's do a shell. So right now, I mean, you can print everything. You can do like ls lr, something like that, guys, and then you are gonna get, you know, full content. You can start exploring everything here. I don't know if config is gonna work. Yeah, it's working. Anything, but if you wanna get a remote shell, you can use netcat. If you don't have netcat, guys, you can always use wget. You know, I mean, or you can upload another shell, which is a uploader. There are multiple ways. So let's assume that netcat is working here in this system. We'd say, and that's actually another recommendation. Well, it could be recommended not to have netcat running, but in these scenarios, the attacker is gonna upload it anyway. So we're gonna do this. We have another system, which is this one, okay, with the IP 130, same mask, but 130 at the end. We're gonna say netcat listened on the port 80, which we're gonna be waiting for the shell here, okay? And then in this case, we're gonna say, okay, so let's try to connect to the IP. Netcat connect to this IP 130 to the port 80. Sometimes the port 80 is good because if you want to try to do a connection, outbound connection, if it goes to the port 80, can be accepted by a firewall. If you put another port, might be rejected. And then we said send a shell. We execute it. We see that it is like kind of doing something. So let's go to our attacker machine. We said that we got a connection, and guys, we are inside the machine. We can see it's Linux, our ID, data, host name, CSTT, and whatever your imagination wanna do here, guys, it's up to you. We can do like echo Linux. Let's do this. I love this. Linux was here. Oh, forgot something. Oh, let's see if that works. Probably not. We can put it in danux.html. We can print password. You see, so let's see if our file is here. We can just come here. I guess I'm just playing with this, you know. You can do whatever you want. Okay, so you just found how we can get a shell via the database successfully. It's cool, right? Let's do it with SQL Map. SQL Map can also do it for us. So with SQL Map actually is pretty easy. I love to do it manually though. With SQL Map, what we can do is we can pass the option OS shell. That's it. And we're gonna need, well, we'll see. We can say that what is the language? We say that it's PHP, and it says, hey, do you want me to brute force the document root, or you can give me a specific folder? We know that in this case the specific folder is this one, spark www OWASP practice upload. We know that it is the right one. That's it, guys. We got the shell. Same thing. ID, your name, host. So if config. So we got a shell. We got a shell right here, and anything, guys. Again, you can see here is my Danux. Everything. So you got the shell. You can always search. You can see that here they said they uploaded this guy. Okay, so we can go there if you don't want to use that shell, whatever, or you lost the shell, which is very common. You can see that it is also waiting for a cmd command, and again it is the same story, guys. Oh, this is better. It formats everything. Cool. The most important thing here is just to finish. We found many vulnerabilities. These vulnerabilities, keep in mind that we should always document it. You remember we have our access, and in our organization, probably let's say that we found another child, another host. Let's say that in this case is CSTT. Okay, guys, so then we have another, which is SQLE, whatever we found here, and then we might wanna store our shell that we just got, and obviously all the injections that we did. All the injections that we did. It's pretty important to document it, guys. Keep in mind that you need to document all your findings, so that all other guys can say, hey, I'm gonna go to rest. Another guy comes and say, hey, there is a shell, I can use it, you know. And finally, how we can get rid of this. That's also very important, right? So let's see here in let's go first of all to our folder. Let me show you how you can fix it. First of all, how you can fix the SQL injection? Simple. Parameterize SQL queries. I always says the same. It's pretty simple, but it is the way it works. So in this lesson 1, I have already implemented what it is. If you remember, let me open. Here we have our SQL. As you can see, we were concatenating the values, and obviously in the index sec, what we are doing is we're doing parameterized. So basically what we are saying is, first of all, we change our connection. We use PDO. Let me show you. So basically we're using PDO library, which help us to do parameterized queries. Okay, so here we're saying, okay, I'm not gonna concatenate the values. I'm gonna add it as bind values, which means the way it works is that the SQL query is gonna be sent this, and in a separate transaction is gonna be sent this. It's not gonna be concatenated, and these values, the user and password are gonna be validated, are not gonna be treated as part of the SQL statement. And just because of that, we can fix it right away. So let's just move index sec to index, and we can go to lesson 1 again and check. You remember we were able to do single quote here equal 1. You remember that? We were able to bypass it, and we can see now that it says invalid username and password. If you apply the same patch, sorry, not the same patch, the same implementation on every single query, you are going to avoid SQL injection that easy. Now, let's suppose that you have SQL injection, for some reason it was bypassed. Let's talk about the remote shell. We got a remote shell, and the reason we got it was because we were able to write into the upload file. If we go to the upload file, you can see that the upload file has 777 because it's expected to upload everything. But we just changed this guy to this. That means now only root can write on it, no one else, especially MySQL. Let's try to replicate these guys again. So we're gonna do here the 03, and where was my injection? It is not here, so let's try to do it. Okay, so we said it's right here. So we're gonna try to do this guy again. Let's try to use 5. It says can create write file, right? Because MySQL is trying to write into that folder, and just because MySQL is not allowed, we just deny it. That's one approach. Let's put back the permissions. Search mode 777 to upload. Okay, it is right exactly as before, so this guy is gonna work again. As you can see, it's working. So the second approach is to remove the permissions of this guy. So for that, I have my notes here, and the way we grant, we can revoke. Okay, guys? So we can say something like, we connect to MySQL. We connect to MySQL. We change to OWA use, well, we don't need that. We say something like revoke. Let me just grab, sorry, I'm gonna grab this guy. We know that the user is defender for this database. So what we're gonna do here, guys, is we're gonna remove the permissions of this guy. And the way we remove it is by saying revoke the file. File The file permission allows a user to write into the file system. From. Okay, so now if we try to execute it here, even with the directory with 777, it says access denied. So we learn multiple ways by fixing the code, also by changing the MySQL parameters, and finally the directory permissions to prevent all those different scenarios. Those different things must go into your reports so that you can present it to the developers during the finding session. Hope you enjoy it, guys.